So this is case one of integrating rational fractions. So when the factors of the denominator or d of x are all linear and none is repeated. So when you say linear, so it's in the form ax plus b. Okay, so the partial fraction is written as a over ax plus b, where a is a constant that needs to be determined. Okay, a constant. And ax plus b is the linear, no, factor. All right. So for example, if we have x minus 5 all over x squared minus x minus 2 for the fraction, so it's a proper fraction because the degree of the numerator is 1 and the degree of the denominator is 2. So 1 is less than 2, therefore it's a proper fraction. So we need to resolve this into partial fractions. So the number of linear, or rather, yeah, the number of linear factors will be equal to the number of partial fractions that we need to form. So this is a quadratic no expression. X squared minus x minus 2 is a quadratic expression where the degree is 2. So meaning if it's factorable, so assuming that it's factorable, so we'll form two factors. So meaning we'll have two partial fractions in the form a over a over a sub 1 x plus b sub 1. Okay, and another linear factor, or rather another partial fraction having a linear factor, another linear factor for the denominator. Okay, where a1 b1 a2 b2 are constants. Okay, that we also need to determine. So we need to solve for these values. Okay, so let me write the method of resolving the given fraction into partial fractions here at the side. So what will be the values of the constants? All right, so we have x minus 5. So let's remove first the integral sign and just focus on the resolving method of this partial fractions, of this fraction rather. So again, okay, so meaning, no, um, we need to factor out x squared minus x minus 2. So let's do that first. Okay, so it's factorable, no? We have x minus 2 and x plus 1 for its factors. So two linear factors, so meaning two partial fractions. Okay, so it would be equal to, okay, so let me write the corresponding, okay, fraction here at the side. Sorry. So it's correspondingly equal to a over x minus 2. Okay, this is the first partial, no, fraction. And the second partial fraction is b over the second linear factor. So b over x plus 1. So we need to solve for the values of a and b. Okay, so step 1 is to multiply, okay, the equation by the denominator. So the purpose is to express the left side and the right side as polynomials and not as fractions, so that we can easily solve for the values of a and b. So multiply the equation by the denominator d of x. Okay, so meaning we need to multiply the left side with x minus 2 times x plus 1. So you can skip this part. So if you can easily picture out what happens to each term if you will multiply it, no, with the denominator, then just this skip no the part wherein you need to write, okay, the x minus 2 and x plus 1. So you can right away put the result, okay? So after multiplying it with the denominator, of course, we cancel out the denominator. Again, the purpose of doing this is to express, okay, the term as a polynomial and not as a ratio no, of polynomials. So x minus 5, okay. And for the right side, so you need to do the same thing. Multiply a over x minus 2 with x minus 2 times x plus 1. So the result would be we are canceling out, okay, x minus 2, right? And for the second term, so multiply the same value. Okay, what you do to the left side, you need to do it on the right side because it's an equation. Okay, so each term must be multiplied by x minus 2 and x plus 1. So the result for the second term is x plus 1 will be cancelled out. So the result would be a times x plus 1, which is now a polynomial and not a ratio of polynomials. Okay, so plus b times x minus 2. Okay, so this is the equation, okay, that we need to use for solving A and B. So for this case, since the result is linear no, equation, so we can assign value to x such that this x plus 1 becomes 0 so that this term will be cancelled out and we can solve for the value of b. Okay. And another step is to assign a value of x such that this term will be cancelled out. Okay. And we can solve for the value of a. Okay. So at x plus 1, it becomes 0 if x is negative 1, right? So second step is assign values to x such that a term will be will be 0 or cancelled out or will be equal no to 0, and then solve again for the remaining constant, either a or b. Okay, so again, x plus 1 becomes 0 if x is equal to negative no 1. So at x equals negative 1, okay, x plus 1 no is equal to 0. So substitute that, okay, after assigning values no to the x, okay. So substitute no the value to all the x's in the given equation or in the equation. Okay, so meaning it's negative 1 minus 5 for the left side. So a times negative 1, no, plus 1, and then plus b times negative 1 minus 2. So this is negative 6 is equal to, okay, this becomes 0. And then we have negative 1 minus 2, it's negative 3 times b. So it's negative, okay, 3b. And then solving for um the value no, of b. So 3b is equal to positive 6. So dividing both sides by 3. So b therefore is equal to 2. Okay. So the third step, so let me write the third step is to substitute x with the determined value. So, for the second term to be equal to 0, okay, b will be cancelled out. So, x minus 2 needs to be equal to 0. Therefore, must be equal to 2. So, at x is equal to 2, okay, x minus 2 is equal no, to 0. So, do the same process. That's 2 minus 5 for the left side. And then a times 2 plus 1. Okay, plus b times 2 minus 2. So, it's negative 3. Okay, it's equal to 3a. And the second term na is 0. So, solving for a, dividing both sides of the equation by 3. So, a therefore is equal to negative 1. So, meaning the corresponding, okay, partial fractions are negative 1 over x minus 2 and 2 over x plus 1. So let's write those partial fractions here na. Okay. So we have already determined the values of a and b. Okay. So let me write no, the values here, the side. So the result would be, again, equal to, so a is negative 1, it's negative 1 over x minus 2, and b would be positive, what was that, 2, okay, over x plus 1. So these are the partial na fractions. So you can double check by adding, okay, the two partial fractions. So the result should be x minus 5 all over x squared, no, minus x minus 2. So we can transfer those partial fractions here and proceed with integration. So negative 1, okay, over x minus 2 plus 2 over plus 1. So since the coefficient of the x terms, okay, the coefficients of the x terms are 1, so we can apply the formula right away. Simple substitution. So u is x minus 2. So du is just dx. Okay. So no need for neutralizing factor. So meaning, okay, the integral of the first term is negative 1 times ln no, of x minus 2. And for the second term, it's 2 times the natural log of x plus 1. Okay, plus c. So this is the answer for this example. So if the denominator has 3 linear factors, okay, so you need 3 partial, okay, fractions.